We want to cover some of the major concepts to think about, some of the key terms you might have heard about, give you some intuition for machine learning. We won't be doing any live coding, so there's no assumption of any math or technical background. But we want to, or I want to make sure you feel kind of empowered to ask questions about things you've been thinking about in terms of machine learning. Think about how you might apply it to human rights problems you're working on, or recruit someone to do the technical work for you, and maybe remove a little bit of the mystery, make it a little bit less sexy than it was when you came into this session. Because you're like, oh, this is actually really easy. I'll just get a data scientist to do it for me, or I'll do a little online tutorials and figure it out. It can seem kind of intimidating when you hear about artificial intelligence and machine learning. And I think the goal of this session will be to make you feel like I can understand this, I can use it to do some good in the world. I'm Chris Kennedy. I'm a PhD student in biostatistics at the University of California, Berkeley. It took me 24 hours to get here, but I'm glad to be here now. And I think my jet lag will be resolved about tomorrow when I'm about to head back. But I've been enjoying DataFest so far and appreciate ODIHR for bringing me over here. And these slides were developed in part based on a RightsCon presentation I gave this summer as well, but updated a little bit to think about anti-Semitism in particular. Yeah, I'm also a consulting data scientist beyond studying data science at Berkeley. So that's where some of my background comes from. I've done a lot of work for political campaigns in the US in particular, and so I think a lot about how to use machine learning to predict how someone's going to vote in an election, how likely they are to vote, what kind of messaging might persuade them to vote for a candidate. So I worked for California's current governor, Gavin Newsom, to help him get elected in 2018. And before that, I actually worked on some Ukrainian elections at the time when they were having elections. So that was a short time period, I guess, but that was a fun project. And if you want to follow along with the slides, this is a bit.ly URL over here. And they're just Google Slides, so you can also look at them after the talk. And also feel free in the future to send me an email if you do end up thinking about machine learning for your own projects and you want to get some thoughts or need a little advice on how to proceed. Yeah, and with that, I want to really emphasize that it'll be more fun for you, and you won't have to hear me talk as much if you guys ask a question or two. So if you're thinking about something for your own project, feel free to raise your hand, and maybe someone else is wondering the same thing. It could be just about an idea you have or a problem you're facing. And the motto of DLab, which I'll talk about next, is it's okay not to know. So it's no problem if you don't really know exactly how to phrase your question, or you're not sure what you're actually asking. Feel free to just raise your hand or just shout out whatever you're thinking about. Yeah, and a little background on DLab. That's the data lab at UC Berkeley. That's where I've been a consultant and an instructor for the past 4 or 5 years at this point. And it's kind of how I got looped in. And we teach classes on R and Python and machine learning. And these are kind of complementary to the academic courses people take at Berkeley, where often the courses are very theoretical, and students found they needed someone to teach them, how do I do this coding to begin with, or how do I get into data science that's not necessarily for research, but it may be helping research. So, question for the audience, maybe someone might fill in. I'm just curious what brings you all to DataFest and to this session. Is anyone thinking about machine learning or a certain human rights problem? Any brave souls? Talk about something you care about? Yeah. Yep.
Well, I am from Ukraine, so definitely after the elections that you probably were talking about, that topic is very kind of rising in Ukraine, and unfortunately now Ukraine is very, very far from deep learning, and of course I'm very interested to get the acquaintance what is that and how to work with it.
Yeah, and that's a good point. I forgot to mention, I guess one of the questions is like, what's deep learning? How does that differ from machine learning, or is it the same? And I'll talk a little bit about that so you have a better sense of what deep learning means, and is it useful or is it hype, and when to use it and when not to use it. So thanks for that. Anyone else? What about on this side of the room? Anyone want to weigh in? Okay, in the back, yeah.
My name is Sergey. I work with the BBC Russia in Moscow, and I'm interested as a journalist. I'm interested in anything that machine learning can do in journalism and in human rights, actually. So this is what brings me here to understand how can I apply machine learning in my journalistic projects.
Excellent. Yeah, and I would say within journalism, the movement to use more data and data science is sometimes called data journalism now, where journalists are really getting teched up and getting more into data visualization and kind of treating data as their source of interviewing, or the kind of the source for creating a story. So if you're doing journalism, I think this could be beneficial to think about reporting and visualizing data. Okay, so let's talk session goals. I mentioned them a little bit, but the major goal is just for you to feel empowered to have a sense of key terms in machine learning. We won't hopefully do too much technical stuff talking about imputation and all that, since that's a little bit more into the details than we want to get. And so whether you're a data scientist or an activist or a journalist and someone who wants to learn more about machine learning, we want you to feel empowered from this talk. And the application that I'll be talking about will be the hate speech measurement project. I don't know, did anyone see the talk I gave yesterday afternoon on the hate speech? Okay, great. So some people saw it. There'll be a slight amount of repetition, but not too much. And I think many of you were attending a different session anyway on the human rights activism track. And I'm hoping that if you're into hate speech or tracking anti-Semitism, we might talk after this session about potentially partnering with the D-Lab and thinking about using our machine learning model that's designed to track anti-Semitic hate speech or other types of hate speech online. So that's kind of what I'm thinking for session goals. And on the hate speech front, I just wanted to mention a couple books that you might read if you haven't checked them out already. I think The Harm in Hate Speech is a really nice book because in the US, in terms of hate speech and anti-Semitism, there's kind of a bias or a leaning more towards free speech, in which the thought is if everyone can just speak freely, then there will be some anti-Semitism, but it'll be canceled out by other arguments against it. But this book makes a good point that with hate speech and anti-Semitic speech, the burden of that is often on the vulnerable population, and that it can really make it difficult just to go about your daily life and feel safe and feel supported in society. And so it makes more of an argument that we might consider a little more removal of hate speech, which is more common in the European context already in terms of regulation. And then, this middle book is more on the free speech front, and the book on the right, Words That Wound, was one of the first books that was making the point that there's real harm in hate speech, and we don't necessarily want to be keeping it up on the internet or on graffiti in buildings. So just a couple of sources. Has anyone read any of these? Run into them? No? Okay, well there's some airplane reading perhaps if you're interested. And a little background on our hate speech project. This has been in partnership with the Anti-Defamation League, the Center for Technology and Society, which I think ODIHR has been working with a fair amount on their anti-Semitism work. We're also partnering with Google Jigsaw, That's the kind of data for social good group at Google that studies hate speech and toxic language on the internet. And we work with the Dangerous Speech Project and the Berkeley Institute for Data Science as well, which is where I'm a fellow over there. So, machine learning for anti-Semitism. Before getting into the machine learning concepts, I wanted to float out, brainstorm a couple ideas of how we might use machine learning for anti-Semitic human rights kind of projects. And I encourage you to think about your own ways of using machine learning for this. So I think a lot of you might be working on hate crimes and thinking about the reports, the police reports that are used to identify hate crimes. And one of the ways we might use machine learning would be to look at past hate crime reports and identify which of those reports were flagged as anti-Semitic based on reviewing the details of the case and which ones weren't. And if we could use machine learning to look at the patterns in the words and figure out how combinations of words like synagogue and swastika and things like that can find patterns and how those relate to that report being flagged as hate speech in some cases and not hate speech in others, then we could use machine learning to look at future reports and potentially automatically suggest this report looks like it should be flagged as hate speech. And that could be a way to help reduce underreporting of hate crimes where the police reviewer might not be trained enough, which is an activity that people are working on, and an area where the machine learning algorithm could be beneficial to ensure the statistics on hate crimes are being appropriately tracked. Photographic evidence is another area where deep learning would be used. The images that are part of the reports could have graffiti, or there could be memes online, and those kinds of patterns can be analyzed by machine learning to try to automatically flag what should be considered a hate crime. Oh yeah, and I was actually at a hackathon at Facebook a couple months back that was about child safety. And one of the groups in the hackathon, just over 24 hours, were able to build a machine learning model that could analyze YouTube videos and automatically find out if a swastika was in any frame of that video. And that's called object detection. And that's an example of how deep learning would learn to create a bounding box around a certain symbol that it wants to find. And based on the pixels and the patterns in those pixels, could automatically flag if certain hate symbols were in there. Swastika might be something that could occur commonly, and it might be in a lot of videos that get missed. So deep learning could be useful there to kind of automatically go through the millions of YouTube videos that get posted every day. Social media comments, that's where our hate speech project is analyzing hate speech and automatically able to measure, is this targeting Jewish individuals? Is it encouraging violence or humiliation? And given the volume of social media comments, we need some sort of automatic method to go through those. We talked about YouTube, crime hotspot detection, figuring out where hate crimes are happening and ensuring that there's appropriate police coverage. There was a recent project out of the University of California, Davis, in which they created an AI model that would automatically respond to hate speech and say, based on example responses that humans provided, it would create its own response that would say, criticizing someone for their race is not right. Like, you shouldn't be doing this online. And it was able to, I believe, kind of reduce the future hate speech by those individuals because they felt like they were being watched and there was some normative reaction to say that's not right. Also, flagging of code words that untrained individuals might not miss, like 88 is a code word for Heil Hitler is, and there's a lot of those code words that the Anti-Defamation League and other groups are tracking. Okay, so question for the audience. What kind of applications of hate speech are you thinking of? Could be for anti-Semitism, it could be for something else. Anything that comes to mind, you know, based on these topics or otherwise?
It could be used against misinformation and disinformation, I think, based on machine learning and what kind of disinformation some groups are trying to spread.
Yeah, there's a lot of research on disinformation and misinformation and how to use machine learning to automatically detect it, and then, yeah, similar to this counter speech intervention, potentially say, you know, this is not right, here's a link that disproves this fake news or whatever, and that could try to reduce the spread of that, and that could lead to better information in democratic elections or in other situations. Yeah, that's a big one. Okay, so what is machine learning? We've talked about different applications. I've got two definitions that we came up with for machine learning. If you come from more of a programming background, machine learning could be seen as a flexible type of programming where we give the computer, here's the input data, and that could be like hate crime reports or images of refugees or survey responses, and you tell it, this is how I would classify that set of examples. This would be a photo of a refugee, and this is a photo of, you know, a general population or non-refugees. And you don't have to program the exact algorithm of how it can determine the patterns. It will try to automatically create those, detect those patterns and figure out how to program itself, essentially. I also think of it more as like an educational or teaching approach where the AI is kind of the student, the human is a teacher, and you're saying, here's an example of this type of crime reports, and here's these examples of these other type of crime reports, and it tries to figure out in the future how would the human have classified that data based on the examples I've seen. So in most of these use cases, the biggest task we have as the humans is to create the different buckets of examples and hopefully get a lot of data for each of the different examples we want. And then we kind of apply the machine learning algorithm, let the computer figure out how to differentiate the two. And then that lets us scale up whatever analysis we want to do to millions or billions of observations, which would not be possible for humans to do on our own. Any questions on these definitions, or would someone have a different approach? Yeah.
Well, it's not about the definition.
Okay, yeah.
I was wondering what level of programming skills do you have to have in order to work in machine learning?
I would say you used to have really just basic knowledge of R or Python or Java. Almost any programming language has its own machine learning framework or library. But actually nowadays, you don't even have to be able to program at all. Google, I think this past week, released a new automatic machine learning system. I forget the name. Does anyone remember the name? They just posted it last week. All you have to do is create the examples. So you would upload like 100 images of swastikas and 100 images of non-swastikas. It'll do the programming automatically and build a machine learning model for you. So we've gotten to the point where you don't have to be a programmer at all. The tools are online. It might be a little more expensive, but it's going to save you a lot of time if you're not already a developer. So it's pretty sweet to have it be so open for all of us to build machine learning models with a couple mouse clicks. And I think Microsoft and IBM and other startups are coming out with similar systems. So it's a cool time to be so empowered to use AI. Yeah. Other questions or comments? Okay, yeah, and then I would say, as we're thinking about building our own machine learning projects, there's really 3 steps to the project. You want to be thinking about what is the source of data that I want to be analyzing, and what are the types of questions I could ask from the data. Then we need to collect the examples, and we want to build the highest quality data sets of the examples, because we know if we have a biased data set and we feed it to the machine learning algorithm, it's going to be returning biased results. And that's one of the dangers of machine learning, and one of the things we want to be really proactive with, to think about how has my collection strategy potentially led to bias. Could be gender bias or racial bias, things like that. And then the third step is build the model, which could involve a little bit of programming. Nowadays you can build a machine learning model in one line of code. So it's not even a lot of code if you are a coder. And then in some amount of review of potential bias. And I'll also, to go back to that question, if you have done a little bit of R, I'm teaching a machine learning workshop tomorrow that will teach you how to use R, the R programming language, to build your own machine learning models from scratch. Okay, and as you're thinking about machine learning for your project, I think there are really 4 kind of strategies for how you might go about doing it. First would be, most straightforward would be to find a vendor or consultant that could build the machine learning model for you. And so they would be an expert, and you get to work with them, and you wouldn't have to know as much of the details about different algorithms or what is the best way to gather the data. If you're at an organization, then you have the potential to work with an existing data science team, or do a little bit of hiring and create your own internal team. That's going to give you the best long-term capacity to use machine learning on multiple projects over time and have better internal capacity. Because one of the risks with number 1 is that when you're working with an outside vendor, you kind of, if you don't have expertise in machine learning, you don't really know what you're buying. You don't know how to evaluate the quality necessarily of the machine learning models. So it's kind of a chicken and the egg, that in order to really know if the vendor is doing a good job, you need to have internal expertise in machine learning often. So it might be best to go with number 2 to begin with. 3, if you're a data scientist or you want to get into coding, it's really not that difficult to build your own machine learning model. And now that we have these online tools, you might not even have to be a coder. And then 4th, especially on the human rights front, you might consider working with a social good organization like DataKind, where they could work with you and have data science volunteers act as consultants, essentially. Or you might recruit your own volunteers. Because a lot of times, data scientists are working on predicting clicks of the latest ad, or how to optimize revenue for a corporation, and they might really appreciate on the weekends or at nights working for a good cause. This is an example of a robot learning how to read text in a good AI-related movie, Short Circuit. Let's go on to a couple key terms that you might have heard about. Starting to get a little bit into the technical details. Model. What does a model mean? Model is basically some algorithm, and an algorithm is kind of a procedure or a series of steps that would kind of be looking at statistical patterns that gets applied to some data set, and it's trying to learn the true patterns in how the data are related, while at the same time avoiding random noise. So if you think about, if you had 100 photos of refugees and 100 of non-refugees, as humans, we would be able to make out patterns of people and scenery, but there would also be random noise. So any given pixel might have some noise in it from the photo, or it could be raining. And so when we're creating these models, we want them, without being humans, to be able to detect patterns that are truly related to differences in the examples, while not focusing on random noise that it's not reflecting a true pattern. The next most important term, I call it an outcome variable, but you might also hear it called a target variable, a response, Y, or a label. That's what we're trying to predict. So in the case of the refugees, the outcome variable would be, is this a photo of refugees, yes or no? For the hate speech project, our outcome variable would be how hateful is a given internet comment. It could be something like, what's the age of a person in a photo, or what's their race? That would be another type of outcome variable. Then in order to predict that outcome variable, we need the input data, which is called variables or features or the X data. Those are the measurements we made on all the observations that we're using to predict the outcome. So with photos, the X data would be the pixels in the images. And the algorithm is going to try to look at patterns in those pixels to try to predict what's the outcome value. And the model is really learning how to take the X data and get a prediction of the outcome data, so that in the future, if we only have the X data, we can get a prediction of what the outcome data, what's our best guess of the outcome data. And then lastly, accuracy is the most common way to evaluate machine learning models. That's a metric which tells you what percentage of the predictions of that model are correct. So if it's getting all the predictions wrong, you'd have 0% accuracy, and if it's always predicting the right answer, you'd have 100% accuracy. And that's a common way to have a metric for how good is the model. Questions on any of these or other terms? Yeah.
How large is the data set for the training? You said 100. Is it really that small?
Good question. Yeah. How big of a data set do you need to use machine learning? It will vary by how difficult the problem is that you're trying to predict. So I think there's not really a clear answer. It used to be that for deep learning, you would want to have millions of examples. And so that would not really be feasible for a lot of human rights projects. But what they've done is they've learned how to use transfer learning. And that's where you build the model, you kind of start building the model on an existing data set with millions of images that it's not related to what you're trying to predict. Then if you only had 100 examples each of whatever you're trying to predict, you kind of update the model for your specific data, but it's not being built from scratch. It's only adjusting the model that was built on this huge data set. And so you're kind of transferring the knowledge from this huge data set to the smaller thing that you really care about. And so it kind of learns to see images in the large data set, and then it adjusts those patterns to best classify the smaller data set that you're working with.
So in the example that you provided with the refugees, how would you kind of do that transfer? Like what would be the original data set that you would transfer over?
The original data set for images would usually be what's called ImageNet. Has anyone heard of ImageNet? Yeah. Are you a data scientist or? Oh, okay, yeah. ImageNet was created at Stanford in 2012. It's a database of around, I think, 10 million images that have been classified into 1,000 different types, like chair or bobcat or beach. And data scientists have built machine learning models to do really well on that huge database and built these really complicated deep learning models like Inception or ResNet are some common ones. And now any other analysts like us can take those models that have been trained to kind of see images on their own and adapt them to the images we care about. So I would say if you're doing image-related deep learning, you could start with even fewer than 100 examples. You could even do 30 examples of one thing and 30 examples of another. And through transfer learning, the model can still do pretty well at detecting patterns. But that said, you're going to do better, the more examples you can generate. So if you can get to thousands or tens of thousands, that's going to be a more ideal sample size. Any last questions? Going once? Okay. So that was kind of machine learning overall. Let's talk about 3 subtypes of machine learning. Supervised machine learning is what we most commonly think about as machine learning, and that's what most of us want to be doing when we do machine learning. That's using our X variables, some sort of input data, which could be images or hate speech, comments, or audio recordings, and we want to predict some outcome variable Y. And it's called supervised because this is kind of the right answer. And so we're telling the algorithm, learn how to determine patterns in X to predict Y, and we'll tell you, are you right or are you wrong? By contrast, unsupervised is where we don't have an outcome variable. We're just trying to figure out patterns in the X's. So that would most commonly be clustering, where say we have an email list of donors or something, we want to figure out what are the different types of donors in my database. We would use unsupervised learning to create groups, subgroups of our email list or some sort of database where we have X's, and there's no correct answer. So we don't have a Y, we can't tell if those subgroups are correct or not, but we still might find it useful to divide our data set into partitions. And then the third type is called reinforcement learning. And with reinforcement learning, this is really more for robotics. We want the machine learning algorithm to figure out what's a sequence of actions that would lead to some sort of positive outcome. So if you're building a robot, you might say, I want you to go defuse a bomb somewhere. And I'm not going to program you explicitly because machine learning, we're not trying to program the exact steps the algorithm takes. We just wanted to figure out that you need to kind of use your camera to go forward, then use a grabber to find the bomb and clip the right color wire or something. Reinforcement learning would be how you would train an algorithm to do that automatically. But it could be any sort of long-term reward. So in the future, we might have AI that is using reinforcement learning to be a campaign manager for a politician that says, this is how you should allocate your ad buy, or I think you should do a speech at TSU next week because we need to get the students on board. And I think that over the course of the next 3 months, if you rally the youth vote, you're going to beat out your opponent. Right now, this is what human campaign managers will tell the politician what to do. But if you had a large enough data set of what prior campaigns had done, you could use reinforcement learning in theory to have a strategy of how to win an election. Reinforcement learning is also used in medicine because it's kind of what your doctor is doing, where you want your health to be as high as possible in the next year, and you have medications you might take or tests you might do, or maybe you need to exercise. And so if you could analyze prior patient data, reinforcement learning could say, next week you need to go in for your checkup, and then based on your blood pressure, I'm going to recommend you take this medication, and based on prior patient data, I think this will maximize your life expectancy. So we're probably going to start seeing machine learning used for reinforcement learning in the future to possibly advise doctors on what course of action is recommended. But this is probably a little bit more, it's more difficult, it's more error prone. So we're largely talking about supervised learning in this session. Questions or comments? Yeah.
We had a question about how big your data can be, and I have a question how complex it can be.
What do you mean by that?
I mean, for reinforcement, for instance, how complex of a data set can you have to predict something?
Yeah, as complex as you want, I guess. For medicine, people use electronic health records for this kind of analysis. So all the medications any patient has taken at a hospital and all their prior surgeries, you could have thousands of variables. Reinforcement learning is also used for self-driving cars. So if you think of the cameras that are on the self-driving cars, they've got billions of hours of footage of pedestrians and stop signs, and they're also monitoring the speed of the car. And the reinforcement algorithm is determining, how should I turn the wheel? Should I brake? Should I accelerate? I'm about to run someone over. So basically at this point, anything a human could do would be the kind of complexity we're looking at for machine learning. It might take a really good algorithm to get close to human performance, but we're starting to be at the point where deep learning and machine learning is getting close or sometimes exceeding human performance. Yep.
That's a follow-up question. So in that example, what do you build the reinforcement machine learning model on exactly? Is it just a lot of data for it to have that sort of intelligence?
Yeah, it's really all comes down to examples of what you want it to learn. So it would be examples of humans driving a car and not getting into a wreck and reaching whatever destination, like say a self-driving taxi wants to get to. In our case, we want to be able to track hate speech over time. So historically, how has hate speech changed? And in the US, the Donald Trump presidential campaign and now presidency has potentially led to an increase in hate speech, but we want to have a really accurate way to measure that over time and not just anecdotally feel like it's increased. So that's where the model could be useful. We need to have a large data set that it would be too difficult for humans to review, and that's why we need algorithms. And then I think what we want to get to is real-time interventions. So if someone's typing in an anti-Semitic comment onto Facebook, and we could have a model that could detect that in real time and say, are you sure you want to post this? Like, this does not seem to be appropriate. That might be a way to reduce those comments from ever happening in the first place. And ultimately, we want to kind of eliminate the link between hate speech leading to hate crimes or terrorism or genocide. We want to be empowering vulnerable populations to not feel like they're getting attacked and that they're not being supported. And I think we also want to see how, if we can apply counter speech and supportive speech, we could help de-radicalize these individuals and not have to be as reactionary to those kinds of attacks. One other book recommendation as you're thinking about using machine learning for your own project is this Constructing Measures book by Mark Wilson at Berkeley. This is a book that really inspired us on the hate speech project to think about what is the outcome variable that we're trying to measure. It could be, the refugee-related project. It could be for journalism. And it really encourages you to think through, how would I define hate speech or whatever construct I'm coming up with? And based on that theoretical understanding, what's the type of data that I want the human reviewers to be recording that would allow me to measure it as accurately as possible? And this is an example of the Anti-Defamation League's Pyramid of Hate. This was a big inspiration for our work, where based on historical analysis, they developed a theory that hate speech and hate crimes would often begin with at a lower level of bias that then leads to possible vandalism or acts of prejudice, and then leads to increasingly kind of intense and negative repercussions. And that this is kind of the radicalization as we go up. And so as you're thinking about machine learning for your project, you might not have this granular of a theory, but you want to be thinking based on the literature and prior news articles and things like that. Before you get to the technical data analysis, try to have this kind of theory of higher and lower levels of whatever you're trying to measure.
And that'll help you get a better sense of how to design your machine learning model.